Alright, absolute versus incremental modes. So what is absolute? What is incremental? Now we have talked about this a little bit before, but the things to keep in mind are that one of these is a lot easier than the other one to do. People use both. It's not a big deal. But absolute programming is much easier for beginners than incremental programming. Now initially you might not think that way, but once you see it a little bit or start doing it, you'll see that it is much easier. So absolute mode is when you're always basing everything off of 0 or your part origin. Incremental mode is when you're basing everything off of wherever the tool is at the moment. So let's look into this a little bit deeper. Here's our Cartesian coordinate system, x, y, and z. We have our point of origin. So our point of origin is right here. And we are going to look at this first off in our absolute mode. So absolute mode. There's a G code to specify what absolute mode is. There's also a G code for incremental. The absolute G code mode is a G90. So G90, that's one of the first things you're now going to have to memorize. But G90 sets the program into absolute mode. You can switch between absolute and incremental as you're programming, but I just recommend staying on one throughout an entire program. So we put in a G90, and that would then activate our absolute mode. So let's look at an example here. So we're going to start out with a little part, and we're going to have a code over on the side that we're going to read. So right here we have a part. It looks like it's about a 3.5 by 4.5 inch block. I'm guessing that because I'm assuming symmetric parts here. And we have a 1/2 inch here. We have 3 inches up to here, so I'm guessing we have another 1/2 inch. So we're going to have 3.5 inches up to here. Over here we have 4 inches. I'm assuming another 1/2 inch. I'm guessing we're having 4.5 inches here. We have 4 holes in the corner, 1 on center. So if that is on center, then 2.25 times 2 would be 4.5, which would be about correct. Or exactly correct, I guess. So let's look at our part. First off, we're going to start out, every program is going to start with a program number. It has an O to start out with. So right here you see I have a program number, starts with an O and 4 digits. Haas machines have 5 digits, some Fanucs have 5, but majority of machines will use 4. It can be any 4-digit characters. It can be, well, it has to be numeric, so it could be 1111, or it could be 1234, or it could be 9999. Doesn't really matter. This is the only time you're going to see an O in your program, is right at the beginning here. So if you see an O somewhere else that you think is an O, it's actually a 0. So keep that in mind. You can have some O's in comments, but you can't have them anywhere else. We then have our first comment. It says center drill. Now center drill is just a comment. So anytime you see anything in parentheses, it's there, but the machine doesn't actually read it. It just ignores it. It's not a command, it's just a comment. Next line of code is our first command. This is the first thing in our program that's actually telling this what to do. So it's a command. We have our N005, which is our sequence number. That's just telling it basically a line number. And then we see a G54. So G54 is our fixture offset value. This actually tells it to instate our program offset. So right here we see our program offset, or our work 0, or our origin, or whatever you want to call it. They all mean the same thing. But what it does is you can use either G54, 55, 56, 57, 58, or 59. There's 6 different fixtures you can use. 54 is the most common. That's the one we're going to use for almost all of our parts to start out with. And that's wherever we're going to set our 0. This is the difference between our machine home, when we home the machine, and where you want the corner of your part to be. That's G54. G90 will set it to absolute mode. So this is going to tell everything to be based off of this corner. And then we have a command here, S600 M03, and that tells it, hey, turn the spindle on forward at 600 RPM, or revolutions per minute. So what it did here is it just basically, you won't see the machine move at all. It doesn't actually go to this location. It just tells it to use that as 0 and then turn on the spindle at 600 RPM. Our next line of code will actually have the tool come over. So you saw the tool come over like that to here. So if I back it up one and then come forward, you're going to see the tool come in here. So this tool comes to 0.5 in the X, 0.5 in the Y. So if this is our origin, 0.5 in the X, 0.5 in the Y brings us to this point. It's based off of here. So it's absolute programming. You did it in a G00, which is a rapid motion. So it's going to go as fast as the machine can go. Now, if you look down below here, we're going to see a block here. This is looking at the part from the front view. So this is the top view, this is the front view. So the tool right here is still up, way up above the part. Because we didn't tell it to do anything in the Z yet. We only told it to move in the XY, so it's up at the machine home in the Z. We now want to bring the tool down to 100 thousandths above the top of our part. So you see the next line of code is telling it Z.1. It has another couple commands in front of it, but down here you're going to see the tool come down to 100 above the part. Alright, so you see the tool came down to 100 above the part right here with this command. Now G43 is tool length offset instating. So it's going to instate the tool length of this tool. H1 tells it to use the offset value in location 1 of our machine. Don't worry about having this memorized yet. That's a whole other lesson. It's just showing that it's here. But you're going to always see this. If we just told it to go to Z.1, it doesn't know what tool's in there or anything like that, and it would come down and crash. So we need to put in this information so that it can come down and instate the length. So it moves it there. Again, note that the coordinate is specified from the program 0. So here's our program 0. It's 0.1 above that. Alright, so now what we're going to do is we're at that location. We're 100 thousandths above this hole right here. We need to drill that hole. And then we're going to drill this hole, and this hole. So we're going to see a line of code down here that has a bunch of information in it. And this is our first canned cycle that we're going to see. Now what a canned cycle does is it gives it some information such as a rapid point, how deep to go, feed rate, all that stuff. And then every hole after that, you just have to give it an XY location, and it will go back up and utilize this information here, and then go to the next one, utilize the information, go to the next one, utilize it. So in our case, we want to drill a hole. So the code to drill a hole is a G91. So you put in a G81, it knows it's going to drill a hole right here. But it still needs more information. It needs to know the information of how deep it's going to go. So in this case, we're spot drilling it, or center drilling it. So we're going to tell it Z negative 0.2. So it's going to go 0.2 into the part here. How fast we're going to go. Feed of 5 inches. So it's going to feed into it at 5 inches a minute. We have an R of 0.1. That's a retract plane. So how far is it going to retract above the part here? R 0.1. So it's going to move 0.1 above the part to go to each hole. So there's our information. It already knows where it's at because we told it up here. So since it's here, it's going to drill the hole right at that location. So it drills it. Next line of code, we don't need any of this information, and we'll keep it in effect. And then I just tell it to go to 3 inches. So it moves up to 3 inches, and at this point, it will just automatically drill a hole here, or spot the hole. You don't need to put anything else in. Again, you don't need to know all this stuff yet. We learned that in a whole nother lesson about canned cycles, but you're just seeing it for the first time right now. So at this location, you'll see this drill is going to come down and do the same thing. Then it's going to move to the center location here and drill a hole there, 0.2 deep. X 2.25, Y 1.75. Now again, those numbers are based off of this origin. So X 2.25, y 1.75. So that's right here. Just connect the dots and then drill the hole. Our next location is x4, y3. So x from here, 4 inches, y 3 inches. So you see 3 would be right here. So I'm going to see it move over there and spot the hole. And then it's going to come down to here and spot a hole there. Again, these numbers are based on, or actually it's going to move to y.5. Yeah, right here. Now you'll notice on this next line, it doesn't put an x in at all because it's not moving in the x. It's just moving in the y. So if I don't put an x in at all, I just put in the y, it's going to come down to here and drill the hole. Now this y value has to be based off of here, not off of there. So I'll see y.5, so it's going to go to y.5, but since it's not moving in the x, it'll be right here. Drills the hole. So I've spotted all 4 holes and the center one. And then I'm going to see a G80. G80 goes back up and it cancels this. So it says, hey, I'm done drilling holes. That way every line of code after this doesn't try to drill a hole at it. So it cancels it. Alright, so that is our absolute mode. It's, in my mind, the easiest way to do the programming. We're going to look at some incremental programming as well so you can see how that's done. And then we're going to compare the two. So incremental mode. What this does is it's always going to base everything on where this tool is. So here's our tool. Everything will be based off of where it is. Our code for that is G91. So as absolute mode was G90, the incremental mode will be G91. So if you want to switch between the two, one line could be G90, the next line could be G91. I'd recommend against it, but you could do that. Alright, so it's always going to be based off of this current position. It doesn't care about this spot here. It cares about the point of this tool. So we're going to assume that this tool is at this location. Tool starts here, right there. So we're going to look at this in a comparison mode. Here's our origin, up in this corner. So it has to come to here, then it has to move to here and here and here, whatever. So we're going to look at it. There's our origin. Just keep that in mind. We're going to look at one side over here is going to be our incremental. This side will be our absolute when it comes up. So we're going to stress both modes. So you see the tools right here. We're going to move up to there, over to here and down. So here's our mode. Here's our mode. G91, G90. Alright, so I look at the first line of code. Notice the yellow dot moved up. I'm going to go away. I'm going to go back one slide here. So I'm here, and I go up to there. So in absolute mode, the one we already looked at, I go to x.5, y negative 0.5. So those numbers are both based off of this point right here. x.5, y negative 0.5. Does the whole. Now for the other one, we're going to see an x of 0, a y of 1.5. Because the tool was right here to begin with, and it moved up to there, you'll notice that where my red dot is here, the x doesn't move at all. So I'm going to have an x motion of 0. But my y is going to move up 1.5 to get up to here. So that's why I'm going to see an x0, y 1.5. Move up to there. Now my next motion is going to be over to here. So I see my command. I'm just going through the parts that I already told you. So my command, I guess I'm going to the center, is in my absolute mode, x 2.25, y negative 1.75. And we'll look at that. Okay, so x 2.25 to here, y negative 1.75. And I get that from here to put my hole there. But in incremental mode, I have an x of 1.75 because in my x, I'm moving from this point to this point. So the difference between those two is 1.75. I get that from taking 2.25 minus 0.5, and that gets me 1.75. Then in the z, right, in the y, I'm going to move from here down to here. So that is 1.75 minus 0.5, or 1.25. From here to here is a negative motion. So you'll see I have a negative motion there. Moving up to here, in the absolute mode, it's pretty simple. 4 by negative 0.5, I get that from taking 3.5 plus 0.5 to give me 4. And in my y, negative 0.5, because from my origin, I'm moving down negative 0.5. But in the incremental mode, I have to base it from here, because that's where my tool was. So my x, I'm moving over 1.75. To get that, I have to take 3.5 plus 0.5 to get 4, minus 2.25 to get the difference between here and here. So again, it's a lot of math. It's kind of a pain. But I get 1.75. In the y, if my tool was here, I need to move up 1.25. The math here is a little easier. 1.75 minus 0.5. But I still have to do math to get there. I come down to here. Now in my absolute mode, I tell it 4 inches because I'm 4 inches over from the side. And then I tell it negative 2 inches because I'm 2 inches down from the top, from the very top. So I do a little math. I have 1 inch, a half, or 1.5 plus a half to get down to here. I could leave out this x 4 inches because I'm really not moving in the x, so I could just leave it alone. Now in the incremental mode, I'm not moving the x at all, so I have a 0 for the x, and the y is negative 1.5. So I'm moving from here to here, negative 1.5, because I'm moving in a negative direction. So there's the difference between the two. You can come to your own decision on if you think one's harder than the other. I prefer the absolute mode. I think it's a lot easier. Some people think this is easier, but there's always pluses and minuses to each, I guess. One negative is that I have to be doing a lot of math in the incremental, I think. Another one is if I make a mistake in this code, every hole from there on out is wrong. And we'll look at that in the next slides. So you see here, what happens if you make a mistake? So the tool started here. I'm going to move up to here and I'm going to drill this hole. So you'll see in the incremental mode, I'm going to move my x 0, so it's not going to move at all. It's just going to stay right on the same plane. And my y is 1.75. Now you'll notice this is a mistake. It should be 1.5 to get up to there. 1.75 would move it up to here. So that's a mistake. It's a mistake on purpose in this so you can see what happens. So you see my hole goes up to here. And it drills. Okay. Now every hole after this is going to be based off of wherever this tool is. So every hole is going to be wrong. Let's see, it moves over to here. This number is actually right, but because this one was wrong, it makes this one wrong. This one's wrong, and this one's wrong. They're all off by that same 1/4 inch mistake. So what could happen here is that you could make one mistake, screw up the entire block, and have to recut the whole thing. Whereas if you did this with an absolute mode, maybe you're wrong on the first hole. But then every hole after that is corrected because it's based off of here. So it moves to here, it's based off that origin, so that one's right, this one's right, and this one's right. So what ends up happening is that maybe you got to fix this one hole, but at least your entire block isn't wrong. Maybe you can plug this hole, or you could weld it, or whatever you have to do, and then re-put it in correctly here, and this block is at least salvageable or usable. So basically what I'm saying is don't use G91 when you're a beginner. After you get good at it and you're doing this a lot, I suppose fine, you could use G91, but for now let's just stick with G90. Alright, that's it for this video.